Okay, hello, hello. My name is Jerry. I'm going to be your teacher for this hour. Today's lesson, we're going to talk about percents. And I always tell my students that if you're trying to get good at the GRE and if you're trying to raise your quant score, the thing to do is get really good at percents and fractions. And so I've already done a video on fractions, so I thought it would be good to do a video on percents for you all. So what we're going to cover today, we're going to start out with just looking at some of the basic mechanics of these percents, how to calculate them, how to read them, what formulas to know. And we're going to learn the difference between the two types of percents that we're going to see on the test, percent of and percent change. We're also going to learn some tools for estimation and using benchmarks, eyeballing percents, and we're going to learn how to translate percent word problems into English. We're going to look at problems in the context of data interpretation and QC and normal word problems for the GRE, discrete quant. So all three types of quant problems, we're going to look at all of these with percents. And hopefully by the end, you'll have a solid foundation after working with some GRE type problems to actually take them on the test. So when we're talking about percents, we're talking about a piece of something. And if I'm talking about a piece of this circle, for instance, I can express that in a couple different ways. One is as a fraction, which is the part over the whole. Another is as a decimal, which is just the part out of one. The one we're focusing on today are percents, which is the part out of 100. Part over whole equals percent over 100. This is the equation we're going to use a lot today. Or you can use a ratio, which relates different parts to each other and to the whole. So like I said, we're focusing today on percents, which is the part over the whole is the percent over 100. And it's important to know that you can convert from a fraction to a decimal to a percent. And as you get comfortable with these, it's important to be able to do this kind of conversion pretty quickly. And I would say especially the one that's really important is knowing that 25% is 0.25, 35% would be 0.35, etc. Being able to express a decimal, a percent as a decimal is a super helpful skill when we start actually calculating these. Another really helpful skill is to be able to use benchmarks to quickly estimate your percents. So the way we benchmark 10% is you just move the decimal place over 1. So 240 becomes 24 if it's 10% of it. And then if I wanted 20 or 30%, I could take that 24, and if I'm good at mental math, and you don't have to be, I personally am not that great at it, you can multiply it by 2 or 3. So, okay, like 24 times 2 is 48, 24 times 3, that's where my mental math gives out. But that's okay. At least I have a sense of these two. For 1%, I simply move the decimal 2 times. So 240 becomes 2.4. And again, I can multiply that 2.4 by 2 or by 3 or whatever. 10% we already know. To get 5%, you just divide that by 2. So 10% of 240 would be 12, divided by 2 would be 6. And then you could add those two together to get 15. At this point, we're starting to get to the point where I would maybe use a calculator. But what's helpful about all of this, I would say the most important of these is knowing how to do these. Know how to take 10% and 1%. And then if you're good at this kind of like dividing by 2 or multiplying by 2 kind of stuff, if you have something like 13%, you might be able to quickly estimate what that's going to be around, right? So at the very least saying, okay, it's like more than 24. It's a little more than 24. Great. And maybe I see that half of 24 is 12. So 24 plus 12 would be 36. That would be 15. So I would be like, cool, it's between 24 and 36. Maybe that's helpful, or maybe at that point you just pull out your calculator. The point is, the big point here is using 10% as our really helpful, important benchmark. So I want you to try this out a little bit. I've got a sheet here of some percents, And I'd like you to try to do as many of these using the benchmark tools as you can, and then check them with the calculator. And just to show you how to find a percent with the calculator, you take 13% of 240. Remember before I said that it was so important to know how to express a percent as a decimal. This is why. If we do 0.13 times 240 gets us our exact answer. So I want you to try to estimate as many as you can. The ones you can't, put in your calculator. I'll give you a few minutes for this, and then we'll check them together. Okay. So it's all right if you haven't quite finished. Here are our answers. So again, for this 1%, we just moved that decimal place over 2 places. For this 10%, we move it 1 place. This one, it's like you can move it 1 place and then divide it by 2, or divide it by 2 and then move it 1 place. Here, we could move it 1 place, multiply by 3, multiply by 8. Again, when we're getting into this territory, I might start using the calculator depending on how good my mental math is feeling. But if you can identify these and the other ones, so again, like 10%, 1%, most important. I would say the other important ones, 25%, 50%. You can get this by dividing by 4, dividing by 2. Then you'll have a lot of these percents, and you're going to be able to see, like if you see an ugly number, you're going to be able to kind of get a sense of what it is without calculating, which can sometimes be helpful if you're fast and accurate with that, if it's easier for you to do that than it is to put it in the calculator. That's up to you. So see if you can use some of this stuff as we start actually doing percent problems. But to lead us into that, I want to talk a little bit about how to translate English sentences and questions we might see into the math of percents. So if we see something like this, which can be pretty intimidating at first, let's just remember that percent just means take that number over 100. So I've got 20%, 10%, 25% Z. Now we have to ask, all right, what do I do with all these ofs? And of, we can translate as multiplication. So if you take 20% of 10% of 25% of Z, you've got it. We could reduce those fractions and restate it as fractions if we wanted, or most helpful. I would say both of these are not ideal to me. Best way to do this, and I'm just showing you this to show how we get there, is using the decimal conversion, which again, I want you to get really good at really quickly. So 20% becomes 0.2, 10% 0.1, 25% 0.25, etc. And so remembering how to translate a number into a decimal, how to translate of as a multiplication. With that, there's one more kind of important translation piece I want to give you, which is something I mentioned before. Our formula for percent of, percent over 100 equals the part over the whole. Now, we also see a fraction is equal to a part over a whole. And this is the way these two can relate to each other, right? We can always convert between these things. But for now, I've got a little bit of a mechanics quiz for you to try. I've got the formulas up here. We've got the percent over 100 is the part over the whole. And keep in mind, any percent can be written as that thing, whether it's a number or a variable, as that over 100, or as 0.01 times that number. So try these out. Don't send me your answers, but let me know if you're done, and let me know if you get stuck on anything. Okay. So just a quick reminder, when you're letting me know you're done or sending me an answer, just send it to me alone and not to everybody. Okay, so here are the answers. And briefly walking through here. So to get this as a fraction, we put it over 100 and then can reduce. To get it as a decimal, we just put a decimal in front of the first two. 18% of 250, I do 0.18 times 250. What percent of 250 is 18? Here, I would do a translation and say, what percent? That's an unknown percent. So x over 100 of 250, I'm multiplying, is 18. And with that translation, then I know where to put my x. Great. So I'm going to multiply both sides by 100, divide both sides by 250. Now, we could also get here with part over the whole, but for me, I find it really hard to know like which is the part and which is the whole. So I do this little extra step just to make sure, because that's an error that I make sure I don't make that error. What is x percent of 250? X percent of 250, 2.5x. 20% of 15% of 250, this is like what we saw on that last slide, 0.2 times 0.15 times 250. What percent of 250 is 20% of 150? So we could say 20% of 150 is 30. And then we want to say, okay, what percent of 250 is that? So what part over the whole times 100? 12%. Another way to do that would be to just do the whole thing. What percent of 250 is 20% of 150? And then solve for x. Would be the other way to set this up. Any questions about anything on here? Okay. Let me just say, as I'm going, if you have any questions, feel free to use the hand raise feature. That'll let me know that you want to ask a question. So we're going to start looking at these in the context of some word problems. And when you're doing a word problem, I would suggest focusing on the following steps as you begin the question. The first is what I call PDA. Put your pencil down, take a deep breath, and actually read the question. It's really important to start by fully acknowledging what's there and centering yourself before you start to actually answer. We then read the whole problem before you start to answer anything. Just read it and see what's going on and try to identify what they want, identify what you have, and then ask, what do you need? How do we get from here to there? And then solve it. So I'm asking you to take a little bit of time in the beginning to really assess what's going on before you start to solve the problem. Going into these two word problems I'm going to give you, we're focusing on using this formula. So I'd suggest read it, and then using this formula, try to think about, okay, which of these three things am I looking for, and which ones do I have? And see if you can set it up, thinking with that formula to solve the problem. Send me your answers when you have them, please. Okay, so as we go through here, we're using this formula to think. In this first one, we're looking for the total number of slices in a pizza. So we want the whole down here. They tell us how many have mushrooms and how many have sausage, and we get what percentage that is. So we know 40% over 100 is going to be the mushrooms and sausage over the total. And then from here, we can solve for x, cross multiply, and then divide both sides by 40. The second one, we do the same thing. Same formula, percent over 100 is the part over the whole. This time they're looking for what percent is mushroom or sausage. So we put in our part, 6, and our whole, 13. And we might just eyeball this and say, all right, it's going to be a little bit under 50%. And then when we calculate it, we find that that's the case. Any questions on this before we take it into a slightly different context? So one place we often see percents are on data interpretation problems. These show up about 3/4 through the quant section. You're going to get a set of 3 or 4 problems, all referencing a graph or group of graphs. And the key with these is that they give you way too much information. So your job is to, first of all, figure out what can I estimate rather than calculate. But secondly, what can I ignore and what's actually important? In terms of how you move through a data interp question, we have to start by understanding the graph and understanding the question. And to understand the graph, it's important to make sure that you understand the kind of graph, like, okay, it's a pie chart or a bar graph or a stacked bar graph. And read the titles and labels. And make sure you can actually interpret the data. So a good trick is to pick one data point on the graph, look at it and say, okay, do I know what that means? Can I explain that? Once we understand how to understand the graph, we have to understand the question. Again, what am I being asked for? Where is that? How does that relate to what they've given me? And what do I need? What can I ignore? Keep in mind, these are never just going to be like you read it and the answer is the number that it says on the graph. You're always going to have to do something to that. It's up to you which of these you want to do first. Some people like to look at the questions first. Some people like to look at the graphs first. It's worth it as you're studying, experimenting and seeing which way feels best for you. But once you understand the setup, then you come up with your plan. So say, okay, have I seen something like this before? And you can look at the answer choices as well and ask, all right, can I estimate with these? Are they far enough apart that I don't actually need to calculate? And then just stay organized with your scratch work. And if you get stuck, be prepared to guess and move on. So let's try one out now. Send me your answer when you have it, please. This one. Okay. So we're asked for the total number of sales in quarter 1. So we're going to be paying attention to that first quarter. We don't really care about anything else. And looking at these, we might say, well, these are really far apart. So I could estimate if I wanted to. How would I do that? Well, using the benchmark tools we saw before. Say, all right, 18%, that's going to be a little bit less than 20%. How would I get 20%? I would take 10% of 1.2 million. And for that, I'd just move the decimal over 1. So 120,000. And then multiply that by 2 would give me 20%. It's okay, it's got to be a little less than 240,000. Only one is going to work with that. Choice D. If I wanted to calculate it, I could take 18% of 1.2 million. So this seems a little silly to me. I would just type in my calculator 0.18 times 1200000. But it's pretty easy to miscount your zeros doing something like this. So be careful as you go. I would also say, if you calculate it, use that estimation as a check and say, okay, let's say I got 2,160. Ask, does that make sense? Could that be 18% of 1.2 million? Seems a little low. So using these tools, both of calculation and of estimation, to help make sure we're accurate. So I had a request to go back to my slide about the data interpretation process. I'll put that back up in case there was anything you wanted to copy down here. This was the one you wanted to see, right? So as we saw in this last one, taking that moment to look at the answer choices and realize we can estimate made the problem a lot easier. So let's try another question. Send me your answer when you have it. Okay, so let's take a look at this. One thing we might notice, again, these answers are really spaced apart. It comes down to powers of 10. Good chance to estimate. So if we're looking for 13 out of 4,000, well, we might say, all right, 1% of 4,000 would give us 40. It shouldn't be $4,000, would give us 40. And that would be right here, which is too big. Well, okay, what if we took it down to 0.1%? That'd be too small. So it has to be between 0.1 and 1, 3%. Using this kind of logic on the test can be really helpful, save you some time. Okay. Getting some questions in the chat about what materials Manhattan Prep offers. I'm happy to talk about that at the end of class today. Also getting a question to talk about absolute value. That's going to be outside of the scope of today, but maybe I can cover that in the next one that I teach. And you should also check out the YouTube page and see if there's anything on there that covers it. Okay, if we were going to calculate this, we could do percent over 100 is the part over the whole, and then multiply both sides by 100 and calculate and get that 0.3%. Up to you whether that feels easier or harder than the estimation. I think with all these, it's really helpful to know there's more than one way to do it and for you to figure out what way is easiest for me. So far we've been dealing with percent of. Percent over 100 is the fraction over the whole. But there's another kind of percent we're going to see on the test, which is percent change. And this has a different formula. Percent over 100, percent change over 100 is the difference over the original. The difference or the change or just one value minus the other value. And the cue for us that we're going to use this is when we see percent increase, decrease, change, greater than or less than. And if we see these greater than or less thans, the one that comes after the than goes in the denominator. So let's try this out. Two problems here. I've got the formula here for you to work with. Again, just like the other ones we did, try to see what am I looking for? What do I need? Okay, so let's work this out. For this first one, we see we're going from Monday to Friday. So Monday is going to be our original. And we have our change over 100. Percent change over 100 is the difference, Friday minus Monday, over the original Monday, times 100%, gives us 500%. The second one, we've got the same numbers, but now we have to say what percent less than the stock of price A is the price of stock B. So A is the one that comes after the word than. So that's going to go in our denominator. When we solve it out, we get 83.3%. Questions or thoughts? So things to keep in mind here. One, noticing, am I dealing with percent of or percent change? I need to make sure I'm using the right formula when I go into the question. If I'm dealing with percent change, what's going to go in my denominator? If we're moving from one day to another, it's the original. If we're comparing with a than, it's the one that comes right after than. So we're now going to start practicing this in the context of some GRE problems. And one type of GRE problem that we're going to play with is called a quantitative comparison, or QC problem. And these are the first problems you're going to see on any quant section. And in simplified form, they look like this. They might give you some kind of upfront info, but they may not give you anything. And then they give you two quantities. And your job is always the same. Compare the two quantities. And if that comparison could change depending on the value of X, if there's a way that you can make it sometimes this, you choose D, that it can't be determined. There are other videos more focusing on these questions, but for now, we're just going to look at a couple in the context of percents. So just know your job is always the same. Pick the bigger quantity, or say that they're equal, or say that it can't be determined. So let's try this out. Okay. So 50 as a percent of 30. So 50 as a percent of 30, right? So like percent of 30. Let me solve for x here. I'll get 166.67. Percent increase from 30 to 80. So my difference is going to be 50, 80 minus 30, over my original is 30. 50 over 30. 5 over 3, and I get 1.6 repeating. Now I did something a little bit wrong here. I misread this. You want to actually just set this up as 50 over 30. Yeah, wait, 50 over 30 equals x over 100. My apologies, I'm getting as my answer is C, but this as a percent of 30 is very confusing to me, to be perfectly honest with you, my friends. So the answer here I'm getting is C, though this is how I would interpret this. This is very strange to me. And honestly, I don't think this is a very well-written question. So we're gonna move on. Important thing is recognizing the difference of percent of and percent change here. Quantity B is a percentage, so you need to multiply by 100, I'm hearing. You are so right. Thank you. I'm so sorry. All right, so we do that, and then we multiply by 100, and we get 166.67. And now they're equal. Thank you so much. It has been a long day. So that's why our answer is C. Okay, interpret quantity A. Okay, 50 as a percent of 30. How did I do that? So the way I thought of it is 50, I'm thinking really here, percent of 30. Another way of saying this is like, what percent of 30 is 50? That's basically how I'm interpreting this. 50 as a percent of 30. What percent of 30 is 50? So 50 as what percent of 30? That's how I'm interpreting this here. Though to be honest, again, I find this really strange, actually. All right, let's do one more, and then we'll wrap up. Okay. So we have an item that's discounted and then increased again. And this is something interesting to know. So first of all, let's notice they don't tell us the item's price. Let's just choose one. Easy one to choose is 100. So okay, we know that original price, quantity A, is 100. And let's now follow this. So if we discount it by 16%, quick way to do that is to do multiply it by 100 minus 16%. So that would be what, 84%? So 0.84. This is the easiest way to decrease something. So 100 times 0.84, which would give us 84. One of the reasons it's nice to start out with 100. And then we increase it by 16%. So we take that 84 times 1.16. So to increase something by a percent, you do 100 plus 16%. Really helpful to know these tricks for doing quick decreases and increases of numbers. And so when we do that, I get, what do I get? 84 times 1.16 gives me 97.44, meaning quantity A is greater. Now, think about the trap that this problem set for you, right? Something we can learn from this is if you decrease by something and increase by that same amount, it doesn't go back to normal. It's going to be different. And this is a trap that the test will often try to trick you with. So it's important to actually do the calculations here. Know that we can't just add percents together. Because as we see, these percents are of different numbers. 84% of 100, but 116% not of 100 instead of 84. So these are going to act differently. Okay. That is all the time we have for today. I'm going to just recap quickly. We're saying, why did we add 1.16? We did not add 1.16. We added 0.16 to 1 and multiplied those, 84 times 1.16. So I took 116% of 84. Does that make sense? So for instance, okay, great. So to recap, percent over 100 is the part over the whole. We use this for percent of. For percent change, we have the change over the original times 100%. Equals our percent change. Knowing the original comes after than. Okay, getting a question. Shouldn't it be 1.6 times 84 in the last question there? The answer is no, and let me show why. So, but good question. So, if I did 1.6 times 84, that would actually be taking 160% of 84. That would be an increase of 60%. We only want to increase by 16. So you could do this in multiple steps by saying, okay, I take 84 and I take 16% of that, and then I add that to the original. That's the same as doing 84 times 1 plus 1.16, or just 84 times 1.16. So to just practice this a little bit more, if we're going to increase or decrease, we want to increase by, let's say, and let's say we're talking about 10%, I'd multiply by 1.1. To decrease, I'd multiply by 0.9. To increase by 20%, I'd multiply by 1.2. To decrease by 20%, I'd multiply by 0.8. To increase by 5%, I'd multiply by 1.05, 5%. To decrease by 0.95. To increase by 50%, I'd multiply by 1.5. To decrease, I'd multiply by 0.5. Is that feeling a little bit clearer? Okay, great. Excellent. Well, good work today, everyone. We covered a lot of material, and I'll say this is just the foundation. So if you found today's lesson challenging, great, keep working with it. If you found you were able to follow it, great, keep going forward. Know that percents can get a lot gnarlier, but it's all the same material. So if you understand these translation tricks and understand these two formulas, you can really do it all. It's just a matter of like how many steps and how many things you have to find in order to go through. So I'm going to stop the recording now.